The Neolithic Revolution, also known as the dawn of agriculture, has shaped our very existence. The age of agriculture was the core beginning of cities and civilizations. One of the integral parts of agriculture is the usage of fertilizer. Humans have been using fertilizer in farming for thousands of years, but has this extensive usage negatively affected our beloved planet?
Similarly to many other processes humans have used to benefit our daily lives, the usage of some fertilizers has resulted in adverse effects on the earth, specifically water bodies. The current situation we face is that farmers have been applying fertilizer, which is rich with nitrogen and phosphorus nutrients, specifically organic fertilizer, which is manure. After application, plants and seeds in the soil consume what they need from these nutrients to grow, leaving the rest of these nutrients in the soil. If that was the case, there wouldn't be a problem. Lands would stay fertile for the next cluster of seeds, resulting in those newer seeds consuming the nutrients meant for the cluster of seeds. Unfortunately, this isn't our reality. The main issue we are facing involves rainwater or snowmelt runoff washing those excess nutrients into rivers and various other water bodies, a process known as eutrophication.
Eutrophication is when an overabundance of nitrogen and phosphorus in nearby water bodies result in rapid algae growth, which many ecosystems cannot tolerate. Significant increases in algae harm water quality, food for aquatic life, resources and habitats, and decrease oxygen that fish and other aquatic life need to survive. Large growth of algae are called algal blooms, and they can severely reduce or eliminate the amount of oxygen in the water, leading to large amounts of illnesses and diseases of local fish. Some algal blooms are harmful to humans because they produce alleviated toxins and bacterial growth that induce sickness if drunk, or if they come into contact with polluted water, or are consumed by tainted fish or shellfish. Our team took an initiative to deal with this problem and find a solution that can be deployed worldwide. Instead of looking to retrieve nutrients after they have been applied to crops, we looked at the problem from another perspective. Through extracting the excess nutrients from the manure when it is applied, we eliminate any potential excess buildup in the resulting manure. Using this method, not only do we stop the problem of eutrophication, but our solution aids in creating a more eco-friendly fertilizer. This would enable us to resell the treated manure to farmlands with little to no access to organic manure, hence increasing the fertility of their farmland. This would also mean that farmers can decrease their dependency on synthetic fertilizers, which not only emits gallons of greenhouse gases during manufacturing, but also results in even greater nutrient runoff in farmlands. Therefore, our team researched and developed a process that allows it to treat manure with a resulting nutrient balance that will not cause eutrophication. In addition, it will create more total fertilizer. Before the treatment process, we first need to separate the liquid and solid waste. This system is designed to separate solid manure from liquid manure from a sludge mixture. The manure mixture is first pumped into the homogenization tank from storage. We then add phosphorus weight to the homogenization tank and mix it until the mixture homogenizes. After the new mixture is formed, cationic polyacrylamide is added and mixed again. This results in flocculation of the solid manure into granules, which can be separated. Here we can see the rotary mixer at the bottom of the homogenization tank, which is the catalyst for both reaction as it cycles the mixture. After the mixing process is complete, the new mixture flows toward the separation screen. At the separation screen, the mixture flows in. It is then filtered with the liquid manure flowing out to the next stage of treatment, while solids continue on and head to the appropriate storage space.
Once liquid manure is separated, it is placed into the liquid effluent treatment system. In this system, there are two parts, one to extract phosphorus and one to extract nitrogen. In the first part, in order to extract the phosphorus, magnesium chloride is added to the liquid manure. This creates a solid substance called struvite, which is a crystalline granulate that can be used as fertilizer. Then, the struvite is filtered out through here, and the rest of the liquid manure continues through the system. In the second part, the nitrogen is extracted by using gas-permeable membranes. Diluted sulfuric acid is continuously circulated through the tubular gas permeable membrane that goes through the liquid waste and back into the acid tank to extract the nitrogen. Then, the liquid manure exits the system and is ready for transportation.
Now we direct your attention to solid treatment. We utilize technology from other pyrolysis reactors to treat the solid manure in order to eliminate the risk of eutrophication. The first step in this process is to load the solid manure by feeding it into the drying chamber. Within the drying chamber are small buckets that carry some of the manure up to the next step, while the rest of the manure is dried up and collected here. In the second stage, the manure heads into the pyrolysis reactor, where any excess moisture immediately dries up just before the degasification process begins. This process allows the solid manure to get rid of any nitrogen and hydrogen it has within it. This is due to the very high temperature within the reactor, ranging anywhere between 450 to 600 degrees centigrade. This range allows us to control the efficiency of the conversion and control the outputted product. The retrieved nitrogen gas from both the liquid treatment and the pyrolysis reactor can be reutilized in the heating stages as a fuel source. This would produce biochar, which is a high-performance organic fertilizer. The biochar is cooled back down and placed into storage, where it is mixed with the previously collected and untreated solid in a 2-to-1 ratio mixture. This creates a fertilizer mixture that is used as a high-performance organic fertilizer, since it contains just enough nutrients so that it will not cause eutrophication. With the three processes, we end up with 3 different kinds of fertilizers, which would not cause nutrient runoff: strovite crystals, treated liquid fertilizer, and treated solid fertilizer.
Moving on to our cost analysis, we found out that all 3 processes combined can finally turn a profit. Previously, developers of these technologies were not able to create profit from their projects, due to each process working individually. Because excess products are shared between processes, we decrease the cost of waste disposal and resources needed. Profits will vary from location to location, but our studies showed that we can have a profit margin of around $200 per ton of waste treated. Eutrophication is not just a problem in Canada, but in fact worldwide. It is a devastating phenomenon that affects millions of communities, farmers, fishermen, marine life, and consumers internationally. Fortunately, with the aid of MTP, we were able to tackle and eliminate this problem, resulting in higher crop yields, more revenue for the farmers and fishermen, and overall healthier aquatic ecosystems. As a starting company and MTP technology, we plan for our solution to benefit our company on a long-term scale, expanding to different areas in British Columbia, then eventually to the rest of Canada. As this will be a long-term solution, consumer demand will increase over time, aiding support for our long-term production and income. We have already surveyed a location to the north of Armstrong, British Columbia, which will be located near the center of an accumulation of farmers' fields. We contacted most of these farmers in advance to collect data about how much manure they produce and the availability of mutually working with those farmers. More research must still be done to complete a case survey of the surrounding location, but results so far show this location to be very effective for startup. MTP plans to start a revolution worldwide, akin to the Neolithic Revolution, a revolution that will push the world into a more sustainable future, where crops are produced sustainably and with higher availability.